recording. This is construction number 4. And we are bisecting an angle. Bisecting an angle. All right, let's start off with just a basic acute angle. All right, so we go here to the vertex, and we make an arc that intersects both rays. Here we go. All right, go ahead and do that at your seat. I'm going to get a different color marker out for today. I highlight those points of intersection. Now, once you have that arc, I want you to look up on the screen. Don't be trying to do the same thing I'm doing. I want you to watch first, and then I'll give you time to do it. Your width of your compass can be any width, but my end result when I'm done with what I'm getting ready to do is I want a point of intersection out here in the middle somewhere. Just watch. So I'm going to put my sharp point here at this point of intersection, and I'm going to make an arc out here in the middle. Don't do it. Just watch. Now I'm going to go to the other point of intersection and do the same thing so that I end up with a point of intersection out there in the middle. Everyone see it? All right, go ahead and do it. All right, once you get that point of intersection, highlight that point of intersection like I did with a dot there, and then use a straight edge to connect it to the vertex. And there we've bisected the angle. All right, everyone good there? That's an acute angle. I think this is the easiest one other than copying a segment. Let's go ahead and do it now for an obtuse angle. So give yourself an obtuse angle. Doesn't matter how it looks. I'm going to do it this way. The steps to the construction are the same. So I'm going to put my vertex on, my sharp point on the vertex. And I'm going to make an arc that intersects both rays. I realize how frustrating this can be if you have a compass that moves on you. Okay, we're going to highlight points of intersection just so they're easier to see. Then we use those points of intersection. Now on this one you might need to widen out your compass. It may not be wide enough as is. It might be. Remember our end result is we want a point of intersection out here in the middle. Don't let your compass move as you go to the other point of intersection. I'm going to highlight that point of intersection. I'm going to use the straight edge to connect to the vertex. And voila. We have bisected the angle. As I said, I think this is the second easiest construction. Okay, the next one, we haven't done this one before for our applications, but we're going to do a straight angle. A straight angle is the same thing as a line. Okay, so straight angle. Let's give a line here. I'm trying to do a horizontal orientation, at least somewhat close to horizontal. All right, now, what point did we use on that line? There's an infinite amount of points on that line. Which point did we use? It doesn't matter. Just pick one. Random. Like this. Random. I'm going to use this one. It literally does not matter. Just declare a point. Okay, once I declare a point, then I follow that. That's my vertex. I follow the exact same procedure. Put that on my vertex. I do an arc that intersects both sides. It's just, if that's my vertex, it's like there's two rays. You just create a straight line. Let's do red. Point of intersection, point of intersection. Now I may need to go a little bit wider with my compass. I don't have to necessarily, but it'd be close, right? Go a little bit wider. Go from both points of intersection. Then I connect the vertex to the point of intersection. And then you probably know this, but if that's a straight line, it's 180 degrees. So if we bisect it, then that's a right angle. All right, how we doing? We doing okay? Like I said, I think this is the second easiest one, other than copying a segment. Al, you good? All right, let's do a couple applications. So the first application we're going to do is 1/4 of angle A. 1/4 of angle A. Now what that means mathematically, you should recall that 1/2 of 1/2 is 1/4. If I liked you, I don't, Caden, but if I liked you, I'd give you $1. If you gave half of that back to me, that means you gave me 50 cents. If I give half of that back to you, that means I give you 1/4. 1/4. I'm just teasing, Caden. 1/4 of a whole is 1/4. Okay, so let's start off with any measurement for an angle. Don't care. You could use obtuse. I'm going to use an obtuse. You could do acute. You can do any measurement for the angle. I'm going to do an obtuse. All right. So the first thing I have to do, I can't just go right to the 1/4. I got to first of all do half. So I go to the vertex, make an arc that intersects both. Boy, have you guys gotten better at doing these constructions. Doesn't it just feel better? I know it still can be frustrating, but versus where you were on Monday, you guys have all gotten a lot better. Okay. Now, once we have those highlighted, we want to get a point of intersection out here in the middle. I'm going to widen mine just a little bit. Point of intersection out there in the middle. Highlight that point of intersection. Use my straight edge to connect with the vertex. And there's half. Now let's do half again. Natalie, you get to choose. Do you want to do this half over here or this half over here? The left or the right? The left side it is. Natalie's choice. Okay, so we're going to go back to this angle. I'm going to do a different width just so you can see that I'm doing it a second time. I could use that same one. But. All right, highlight those points of intersection. I'm going to go from those 2 points of intersection and get a point of intersection out in the middle. That point of intersection is highlighted. Connect it with a straight edge to the vertex. And we actually have this angle and this angle both represent 1/4. I'm going to shade this one in so it looks cool. And that is equal to 1/4 of angle A. Now, you probably realize this, but I'm going to say it anyway. It's what I do. I'm going to say it anyway. I'll give it a different highlighter here. You guys realize that then what's remaining here this angle way over here, the rest of it, then would be equal to 3/4 angle A. You guys realize that, right? If this is 1/4, then that's got to be 3/4. That's a half plus a fourth. Pretty cool, pretty cool. All right, there we got another application yet. We good there? As we've done all week, let's apply it to a triangle. So let's go ahead and make a fairly large, acute triangle. A fairly large, acute triangle. All right, now if you feel confident, go ahead. But if you don't, we're going to go do the angle 3 angle bisectors. If we conjecture a little bit, do you think they're all going to meet in a single point? Yes, they are. So try and be precise and see if you can get them all to meet at 1 point. All right, here we go. Again, if you feel confident, go ahead and do it. If not, stay with me. I'm going to do this one first. I follow the same routine every time. We'll go from those 2 points on the rays. Get a point of intersection out here in the middle. Highlight that point of intersection. Use a straight edge and connect it to the vertex. One down, 2 to go. Some students like to use different colors on each vertex. I mean, that's getting crazy. But I don't mind trying it. Let's see what it looks like. I'm not scared. You also, now look what I do here, you also could get a point of intersection. It doesn't have to be out. It could be like here in the middle of this. As long as you use the same width, it doesn't matter where that point of intersection is. Two down, one to go. Use the third color. Highlight. Highlight point of intersection, connect to the vertex, and we are done. Oh, look at that. Oh, that is good. Look at that. Ah. All right, let me come around and see the evidence of yours. How precise are you? Did you get all three angle bisectors in 1 point? Really close. That's pretty good. If you make your dot big enough, yeah, if your compass is moving on you, this is really hard. And really frustrating. Pretty good. Nice. Look at that. Still working on it, kid? What's that? Ooh, I like that. Precise. Good job. Nice. Still working? Oh, I heard it. I didn't see it, but I heard it. Need help getting it? Alright, I mean, what we got? Two different colors. Really good. Not too bad. Okay, so what do you think we're going to do next? Obtuse. That's right. Go ahead and do it. So give yourself an obtuse triangle and the angle bisectors of each one. Now this is a little more challenging because the smaller those angles are, the harder it is to be real precise. Okay? So give yourself an obtuse triangle. Good. Try and make it big. You know what I mean? Use a lot of the paper. And then angle bisectors. I'm going to do it too. I'm making mine really big, in case you were wondering. Obtuse triangle. One of the angles is larger than 90 degrees. Okay. If you're confident, go ahead and go. I'm going to use this vertex. I'm going to do the obtuse angle first. I kind of liked all three different colors. I'm giving Abby credit for that. Go from those 2 points. Your point of intersection out here in the middle. Highlight that point of intersection. Connect to the vertex. One down, 2 to go. You can turn the paper, you know, if it's easier for you to do it like this. Sometimes I do, sometimes I don't. I think these smaller angles like this are harder. Highlight that point of intersection. Connect it to the vertex. I got to use a longer one here. You might need to extend it so that it meets in the middle. How we doing? Caden, how's yours look? Good job. Alright, I'm going to do this last angle here. Use my third color. I'm going to go from those 2 points. Connect it to the vertex. Oh, look at that. Let's focus in on that. How close is that? Oh my gosh. That is spot on. Spot on. I'm going to come around and look at the evidence, see how you guys did. Good, man. Look at that. Woo. Still going? Kind of fun to do, isn't it? Yeah. I just saw where cases was off a little bit. This is a good thing for all of you to understand. That tomorrow, if yours isn't that precise and you're off a little bit, like they don't intersect, they don't intersect in an exact point, you're not going to get counted off for it. Okay? Literally, what I will do when I grade this is I'm looking at the arcs. Like I'll be looking for these. You see what I mean? To make sure that your arcs are in the right spot. Because if you think of state testing, they're not going to hand you a compass and say bisect the angle. But you're responsible for knowing the constructions. And so what they literally do, I've seen the test, what they literally do is say, okay, do these markings indicate that the angle has been bisected? You see what I mean? And so what you have to do then as a student, you're going to look at the arcs just to make sure, okay, with these arcs positioned like they are, yeah, that would bisect the angle. Or, no, that doesn't bisect the angle. You see what I mean? So that you're physically doing it, you're learning what the proper arcs should be. And that's how I'll grade it. Okay? So I'm not going to look at, oh, her 3 lines didn't meet one single point. Now, if you've got the, I mean this, literally, if your compass breaks in the middle of the quiz, you can literally do it freehand where the arcs need to be and get full credit. Does that make sense? As long as you have the arcs in the right spot. That shows, okay, this is how I copy a segment. This is how I copy an angle. As long as you have the arc showing, the marking showing. Does that make sense? So I don't want you to freak out. Oh, my compass is bad. I'm not going to do well on this quiz. No. Now, does it help you? Your frustration level? Probably. But if your compass just breaks tomorrow, that's okay. You should be able to do it all, even if you get it free. Okay? Everyone okay with that? All right. So one last one before we go, and we're done for the day. I want you to do a right triangle. I'm not going to do it on the diagram, so I'm going to stop the thing, but I want you to do a right triangle and see where it goes. All right? Last one. Okay, let's stop the recording and we'll put it on canvas.